So today we're going to talk about proportional relationships. A proportional relationship is a relationship in which two quantities vary directly with each other. So by the end of this presentation, you should be able to look at a graph and look at a table and decide if they show proportional relationships or not. So here we have a table and a graph. As the table goes up 1 in the x column, it increases 5 in the y. It goes up 1 in the x. It goes up 5 in the y. It goes up 1 in the x, 5 in the y. Oh no, it goes up 4 in the x, but it goes up 20 in the y. So it's still going up at that 1 to 5 ratio. And in the table, you can see it's a nice straight line. The rate is the same, so the slope is the same. But one other important thing you need to look at is, does it go through the origin? So it goes through 0, 0 in the table, and it goes through that origin in the graph, so it shows a proportional relationship. Here's the same proportional table. There's another way to show if it's constantly proportional. You divide your y by your x. 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. And 35 divided by 7 is 5. If you accidentally make a mistake and divide x by y, they're still equal ratios when you divide them, and those ratios show that there's a proportional relationship in this table. So is this a proportional relationship? It's linear. The graph is a straight line, and it goes through that origin, 0, 0, so it's a proportional relationship. How about this one? Well, let's put the points from the graph on the table. Here we go. Okay, so as x goes up 10, y goes up 4. X goes up 10, y goes up 4. X goes up 10, y goes up 4. X goes up 20, but y goes up 8. So every time x goes up 10, y goes up 4. But look, the graph does not go through the origin. The table shows a point not in the origin. It's 0, 10. It's not 0, 0. So this is not showing a proportional relationship. How about this one? You need to ask yourself two important questions. The first question is it linear? The second question, does it go through the origin? If the answers to both of these questions are yes, then it's proportional. And this is a proportional relationship. So this is an important term, the constant of proportionality, that we need to understand. It's shown as 1 comma k, which means what? It means how much the y value changes every time the x value increases 1. Say that again. Every time the x value increases 1, y changes how much? That's your constant of proportionality. So here we go. Here's a graph. As x increases 1, what does y increase? Well, if I go over 1, every time I go over 1, y increases 5. Every time there's another minute, 5 more gallons are used. So my constant of proportionality is equal to 5, or k equals 5. How about here? Well, number of stars and flags. Every time I put another American flag down, I get another 50 stars. So the constant of proportionality is 50. Hint, 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 your constant of proportionality is also your slope. So to sum up, graphs are constantly proportional if they're linear and they go through the origin. So let's see if you understand this. Let's quiz yourself. I'm going to show you a few graphs, and you're going to decide if they show a constant proportionality or not. And if they do, what is it? So here's the first graph. Ask yourself those two important questions. Is it linear? Yes, it's a straight line. And does it go through the origin? Yes. So this shows a constant of proportionality. So what is it? 1 comma k. Every time I step over 1 on the x-axis, y goes up what? So here, be careful, the graph shows increments of 2 going across that x-axis. So if I go over 2, it goes up 15. Go over another 2, it goes up another 15. So if I go over 1, I go up half of that, or just 7.5. Okay, is this linear? Yes. Does it go through the origin? No. So there's no constant of proportionality in this graph. How about here? Is it linear? Yes. Does it go through the origin? Nope. How about here? Is it linear? Nope. I don't even have to ask the second question. And another one. Is it linear? Yes. Does it go through the origin? Yes. So it's constantly proportional. And what is it? If I go over 1 unit on the x-axis, what's my change in y? Go up 1 month, how many centimeters does the plant grow? Go up another month, how many centimeters does that plant grow? And my constant of proportionality is 30. So hopefully now you understand how to find the constant of proportionality, and even to determine, is there a proportional relationship in a graph in a table or not?